What's up, everybody? This is Mr. Gillis coming to you with another video tutorial. Today we've got lesson number 2, which is all about box and whisker plots. And I'm guessing you've probably seen these once or twice before, and maybe introduced in 5th grade, and then probably a little bit more in 6th grade. We're just going to go quickly through this just to kind of refresh you on um, some more ways to display data. Remember, this chapter is about displaying data. So what we want to be able to do today is display and analyze data in a box and whisker plot. We'll start off with some vocabulary, and then I'll show you how to kind of analyze and make box and whisker plots, and to better able show us what our data is telling us. For a box and whisker plot, it's a graph that uses a number line to show the distribution of a set of data. So it's using a number line to showing us how our numbers are distributed, in other words. The lower quartile is the median. Remember, the median is kind of like saying the middle. The median of the lower half of a set of data. And when we actually make a box and whisker plot, that'll be a little bit easier for you to see, I think. And that's just then the opposite of the upper quartile, which is the median of the upper half of a set of data. And then the last one is interquartile range. A lot of times you'll see this abbreviated IQR, interquartile range. And all that is the difference between the upper and the lower quartile. So the lower and upper quartiles. Right, so we'll discuss kind of how to find the upper, the lower, the IQR, and then how to make a box and whisker plot this chapter. Okay, let's look at our first example. And in this first example, we are talking about heights of basketball players, and it's kind of it goes on to the back as well. So there's quite a few steps when we're making a box and whisker plot, but I'll kind of help break it down for you here. So it says use the data to make a box and whisker plot. Here are the heights of basketball players, and these heights are in inches. All right. So just to give you a little bit better of an idea, remember 60 inches is the same as 5 feet, because 5 times 12, 12 inches in a foot, gives you 60. So obviously if it's over 60 inches, these guys are over 5 feet tall. 72 inches, 72 inches would be 6 feet tall. So you can see a lot of these are even 6 feet or greater. So the first step that we always want to do is order our data from least to greatest, and then find the least and the greatest values, the median, and the upper and lower quartiles. These are the things we need to make a box and whisker plot. We need to order least to greatest, find the greatest value, the least value, the median value, and then the different quartiles, right? So Here, what they have done is they've ordered for you the heights in inches from least to greatest. So there's two 67s, and then you can see that they just ordered it here. So find the lower and upper values. That's what we'll do first. Well, it's really easy. My highest value is 85. My lowest value is 67. Done. Next, find the median. And remember, the median is the middle number. So to find that, I just like to cross out my lowest and my highest and keep working my way towards the middle. Lowest, highest. Okay, now I reach a point where I have two middle numbers. If I were to cross both of them out, well, I wouldn't have anything in the middle. So when you find the middle of the two middle numbers, you just find their average. That's why you see they are added together and then divided by 2. Okay, so when you have, I might write that in. When you have two middle numbers, find the average. So to find the average of these two, we add them together and divide by how many numbers there are, which is 2. The other way you can think about that, guys, is you can say, well, here's 73, here's 75. What's in the middle of 73 and 75? Well, it's 74. So our median is going to be 74. Okay. So we've ordered least to greatest. We found least and greatest values. We found the median. Now, lastly, we'll find the upper and the lower quartiles. All right, here's how you do that. You find the median. So here's the middle, right? We had 74 was our middle. Now we find the median of the lower numbers, and we find the median of the upper numbers. So if I were to do that, lowest and highest cancel. Lowest and highest cancel. Okay, what's between 67 and 69? 68 would be our middle number here. And if we do the same here, we got 75 and 85. And now we're looking for what's between 75 and 81. Remember, you can add them and divide them by 2. Okay, so this will be continued on the next page. So why don't you flip your page over and I'll scroll down here. Okay, so here's kind of what I was talking about with our quartiles from the last page is that we had already found out this is kind of simple. We know what's between 67 and 69 is 68. But if you wanted to, you could add these two and divide by 2. You'd still get 68. This between 75 and 81 might not be so obvious. So let's add them. 75 plus 81, 6 and 15 gives us 156. And then we need to divide that by 2. So 2 goes into 15 7 times, which is 14. Subtract, I'd get 1 and bring down my 6. And 2 goes into 16 8 times. So in between 75 and 81 would be 78. I do have some students that don't like to find the average. Instead, they like to line up the numbers. So they like to say 75 to 81. So, and then they do this. So, okay, I'll find what's between 75 and 81 by just using my median method. And it's 78. The same as what I got when I found the average of the two numbers. All right, so now we have all of our data. We've got the high number, the low number. We've got the median, and we've got our first and third quartiles, or sometimes people refer to them as the upper and the lower quartiles. Okay, so draw a number line, and above the number line, plot a point for each value in step 1. All right, so let's make a number line down here. And my lowest number, I think was 60, was it 67? Let me just flip back and look. Yep. And my greatest number was 85. So my numbers should go from 67 to 85 at least, and then I usually like to go by at least one more. So I'm going to start at, let's just say 64. And then I'm just going to go by ones. 65, 66, 67, 68, 69, and 70. 71, 72, 73, 74, 75, 76, 77, 78, 79, 80. Notice I'm just labeling every two, but I'm still counting by ones. 81, 82, 83, 84, 85, 86, and I'm big enough. I have big enough range there so I can plot all my numbers. All right. I'm just going to switch colors here so maybe it's a little bit easier to see. So what I need to do now is I just need to plot all my points that I got from step one. So my smallest number that I had was 67. So I'll put a dot at 67. My greatest number was 85. So I'll put a dot at 85. And then I'll plot my median, which I came up with was 74. If I look back, my median was 74. And then my two values for my first and my third quartile. So I've got 68, that'd be right here, and 78, that would be right here. And now I'll draw a box from the lower and the upper quartiles. Okay, so lower and upper. And this will be my box part of my box and whisker plot. And then inside the box, draw a vertical line through the median. Right, so here's the median. Lastly, then draw the whiskers from the box to the least and the greatest values. And there you have it. You've just done your box and whisker plot. Hopefully that's a good review for you. But so here is a whisker, and here is a whisker. And then I've got my box, and inside my box is my median. And again, remember that this quartiles, what the root word is quart, or if you want to think about it as a quarter. A quarter is 1/4 of a dollar, or 1/4 of a whole. And you can see here's a fourth of information. Here's a fourth of information, my lower quartile. Here's a fourth of information, and here is a fourth of information. So my two whiskers, and inside my box, there are the four quarters or quartiles that my box and whisker plot shows. And again, why am I doing this? Why am I making a box and whisker plot? It helps organize and display data. Just what our chapter title says. It helps display our data so we can visually look at it and not just look at a bunch of numbers. All right, we're going to try that again, another example here. And in this one, it says, use the box and whisker plot in the additional example 1 that we just did, and the one below to answer each question. So here's another box and whisker plot, and it's different than the first one. Oops, I made the wrong click there. And in this one, we've got our lowest number is 64. Our greatest number is 76. The median is 69. And then I've got the lower and the upper quartiles. It says, which set of heights of players has the greater median. So kind of in one way, shape, or form, we're looking for which team is taller, which basketball team is taller. Well, the median of the heights of the basketball players about 74 is greater than the median heights of the, oh sorry, I read this wrong. These are baseball players. And the height of the median of the baseball players is that's at 70. Okay, so the median height of the basketball players is 74. That was from the first example that we found. And then in this height of the baseball players, box and whisker plot, it's about 70. Right, so the median heights of the basketball players is greater. Let's look at some other data. Go ahead, flip the page. Continues on the next page. What else can we say about the comparison of the basketball players to the baseball players? Well, letter B says, which players have the greater interquartile range? The interquartile range is the difference of the difference of the upper and the lower quartiles. It tells how spread our data is around the median. All right, so the length of the box in a box and whisker plot indicates the interquartile range, or the IQR. The basketball players have a longer box, so it is a greater interquartile range. If you want to check and see here, let's look at the length of our box. It's from 70, this would be 74, and it goes to 66. So the length of this box is 8. Go back and take a look at your interquartile range for your basketball players in the first example. It went from 78 to 68, which gives us 10. So like we said here, the basketball players have that longer interquartile range, or that bigger box. So their interquartile range is greater. What does that mean? Letter C says, which group of players has more predictability in their height? All right. Well, the range and the interquartile range are smaller for baseball players. So you can see here the range from the greatest is 76 to 64. 76 minus 64 will give you 12. Okay. And what is the range of the basketball players? Well, if you went back and you looked, the tallest was 85 minus the shortest was 67. So borrow 8. The range for the basketball players was 18, whereas only 12 for the baseball players, which means there is less variation in the data. So the heights of the baseball players is more predictable. Okay? The less variation you have, the more predictable your data will be. That's kind of a big concept right there. I'm just circle that. The less variation there is, the more predictable your data will be. In other words, the smaller range and the smaller interquartile range is going to give you more predictable data. All right, that does it for the two examples. please pause the video now, the tutorial video now, so that you can try these on your own and kind of wrestle with them and see how you do. And let me know if you have any questions. All right, so the first thing that I want to do is I want to, if you remember, order my numbers least to greatest. So what is my smallest number here? Looks like it's 22. Okay, and then 24, and then 27, and then 31, 35, 38, and 42. All right, so 1, 2, 3, 4, 5, 6, 7. This is going to be nice. It's nice when you have an odd number because then you don't have to keep finding averages. So 1 and 1. Work my way towards the middle, a small and a big, a small and a big. My median is 31. Then I need to find the median of the lower numbers, so 27 and 22. So 24 would be the median of my lower numbers. 42 and 35, so 38 would be the median of my greater numbers, or my upper quartile. When I make my number line, it needs to go from about 20 to about 40. I could go by ones. I'm going to go by twos here, just for the sake of not having a huge graph. I'm going to start at 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, and 40, 42, 44, 46. All right. And then I'm going to plot my data. So my smallest number is 22. Put a dot at 22. My greatest number is 42. Dot at 42. My median is 31. So here's 30. 31 would be between 30 and 32. My lower quartile, my first quartile would be at 24. Get that there. And my upper at 38. All right, make my box between my upper and lower. Make a vertical line through the median, and then include my whiskers. So there is your box and whisker plot for that set of data. And then for number 2, it says use the box and whisker plots below to answer the question, which shoe store has a greater interquartile range, or IQR? Remember, that's when you're looking at a box and whisker plot, that's which box has the greater spread of data. And you can see this box here has the greater spread of data. This box is bigger than this box, so that would be Maroon's shoe store. That has the greater interquartile range. If you wanted to find the interquartile range, you'd take 36 and you would subtract 26 and you would get 10 would be the IQR of that problem. So, all right, there you have it. Hopefully you remember a little bit from the first time you saw box and whisker plots, and hopefully this is a good review for you. But if you need more help, remember, always check out those video example tutorials on your My HRW. Right? That's all I have for today. I will see you guys next time.